We've talked about a whole bunch of different factory method operators for the Flux class. We talked about the very simple ones like just and from array and from iterable and from. We talked about interval. We talked about range. We talked about the one parameter version of create. We talked about generate. And now we're going to talk about yet another factory method, which is the two parameter version of create. And of course, this is the one that has the back pressure stuff that we've been talking about, or really the overflow stuff. So let's take a look at this. So here's the two parameter version. What it does, it's similar to the one parameter version in that you can emit a bunch of elements either synchronously or asynchronously, but it also handles overflow. And the first parameter is the one that is used to provide the emitter. The emitter is the thing that generates a bunch of next signals followed by 0 or 1 error or complete signals, so it's the thing that generates the events. And this is more dynamic than the simpler flux, just, and from iterable factory method operators that we talked about much longer ago. Then the second parameter, which is really the interesting one here, is the overflow strategy. And that defines how we're going to deal with overflow. And here are the 5 different overflow strategy enums that you can select from. Now, I think this is a weird use of the word. I like the word overflow. That makes sense. Back pressure doesn't make so much sense to me. Seems like kind of an odd choice of terms, because back pressure to me would indicate that you're trying to tell the publisher to slow down to avoid overrunning the subscriber. But really what this is doing is this is saying, here are the strategies for dealing with overflow. We don't have a way of stopping the publisher from generating data at whatever rate it's choosing to generate. So what we're going to do is figure out how to compensate for that, or how to account for that, or accommodate that by dropping or buffering or something. So it's not really back pressure, it's more overflow. So I'm not quite sure why they called it back pressure, but that's what they call it. And it returns a flux that emits all the elements that are generated by the flux sink, modulo the overflow strategy that you have in place. So it may or may not emit everything. Here's a simple example. We've talked about this before. We'll look at this in more detail in just a moment. So we've used create. We're going to make ourselves an emitter that generates a bunch of big fraction objects in one fell swoop. And then we turn on the error strategy. And you'll see when we run the example, it blows up really fast, which is what we'd expect, because it's overflowing very quickly. Now, again, we could put other strategies in here. We could put in drop or buffer or latest or whatnot. Kind of just a little bit more comprehensive coverage of this. The elements that are emitted from the emitter that's passed to create can come from one or more threads. It's up to you to decide how you want to do it. You can have one thread, you can have multiple threads. And this is not unlike other mechanisms available in other reactive streams frameworks. RxJava has a flowable class that has a create method that's very similar. The main difference is they pass different types. So the create method that's used on a flux has consumer of flux sync, whereas for RxJava they use flowable on subscribe. Not really sure why, but they have slightly different names and different types. Interestingly enough, the streams generate method, which is another way of generating data, does not handle back pressure. So this will just go ahead and blast out it'll generate events ad infinitum, and there's no back pressure mechanisms available in streams. And it's an interesting question why that is. And the main reason why that is because streams is a pull-based model. So you have a terminal operation at the end of the stream, and when that terminal operation is reached, that informs the stream's runtime to start pulling data from the source through the intermediate operations that are part of the stream. And so we never have a problem where the publisher is generating data faster than the subscriber can handle it, because there is no publisher and there is no subscriber. There's simply a terminal operation that's pulling stuff through the stream. In contrast with reactive streams, there can be a publisher that's generating the data at whatever rate it generates it, and that may be faster than the subscribers can keep up. So we have to consider back pressure and overflow and so on in those models, whereas we don't have that issue whatsoever with Java streams. So that's the end of the discussion of the two-parameter version of create. So now I think we've pretty much finished most of the discussions we're going to have about factory method operators in Project Reactor, and we're now going to take a look at a couple of examples to show off all these different features in various interesting ways.